Welcome to Statistics in Excel video number 86. Hey, if you want to download this workbook and follow along, click on my YouTube channel and click on my college website link, and you can download the workbook Business 210 Chapter 8. Hey, we're talking confidence intervals for proportions. Hey, we have an advertising example here, a promotion example. Furnitureland South surveyed their customers, N equals 600, to see if they liked the new line of durable foam furniture decorated in bright colors. 414 said they were excited about the new line. All the binomial tests are met. So the question is, we want to build we'll first calculate P, our sample proportion, and then calculate an interval so we can be pretty sure that it's within the two confidence limits. All right, let's calculate our P equals our number of successes divided by our sample size. So 0.69, our sample proportion, is the best estimate, of course, for our population proportion. Of course, even though it's an estimate, we need some room on either one because we know there's sampling error. This very rarely, if ever, comes out to be exactly the population parameter. Let's scroll on down here. Our level of confidence, we're going to be pretty sure about this one. Now, in some of our earlier videos, we've used 90, 95, and here we're going to do 99. Alpha means the risk that our population proportion will not be in our interval. Wow, is this one going to be low? We're only willing to take a 1% chance. Now, alpha divided by 2, wow, that's like a 0.5%. So that one divided by 2. Now we can calculate our z. We've done this a number of times with a proportion. We want it on the upper end. The way it works is all the way from negative infinity to wherever our value is. So we'll give it half of alpha here. But 1 minus, because if it always goes from negative infinity up to whatever that marking point is, this half alpha, a little bit on the top, a little bit on the top when we plot it. So 1 minus this will give us exactly the z we want, 2.57. Now our standard error, our square root. And remember, it's p times 1 minus p divided by n. So we'll go up and get our p times, in parentheses, 1 minus our p. Oh, I got a 9 there. Oh, got to be careful like that. That would be pretty big, times 91. And then divided by n. Now, as we've said a few times here, n is right there. The order of operation does this perfectly without putting parentheses around this whole thing like you'd have to do if you were doing it by hand. All right, so there we go. Our standard error is going to be 0.01. But really what we're interested in is our margin of error, which gets added, subtracted and added to give us our interval. So as we've seen a number of times, it's always going to be our standard error times our z. You know, whatever it is, whether you're doing t distribution, it would be t times the standard error. Remember, the standard error is just the term for whatever standard deviation for the sampling distribution you're talking about. So our error is always going to be either z or t times some standard error. So we got it there, margin of error, and there it is. That's the amount we have to subtract and add. So let's get our intervals. The first one will be 0.69 minus our margin of error. And this one will be equals plus our margin of error. And there it is. The owner can be 99% sure that the population proportion, that is the percentage of customers excited about the new product, is between 64.14 and 73. The margin of error is 4.86. And so the owner can probably be pretty sure that this is going to be a hit. That means we can go get our durable foam furniture decorated in bright colors. All right, we have one more video for this chapter coming up, sample size. All right, see you next video.